Is it possible to predict how people will act in a pandemic? This is a worst-case scenario that Dr. Henry has repeatedly warned about.
What this shows is that we do have a possibility of having explosive growth in our outbreak here in BC.
We can prevent this, as long as we stay below a contact threshold. We know about this contact threshold because of one of BC's COVID-19 models. But if we have trouble forecasting the weather next weekend, how can we forecast a pandemic? What is a mathematical model anyways?
Yeah, that's a deep question, right?
That's Dan Coombs, and this is Colijn, two of the architects of BC's COVID-19 models.
And we do forecasting and other kinds of estimation within BC CDC to answer questions they have that they're asking us, and also to answer questions we think they should have or will have in the near future.
Let's take a look inside the model they built. It's made up of a bunch of compartments representing people's COVID infection status.
So this if you were an individual in our model, you would sort of start off over here unsusceptible, and you would work your way through the stages over to the recovered class.
This process is simulated through mathematical equations, moving people between the compartments.
And then the infectious individuals can, of course, contact susceptible individuals, and they can cause new infections.
Eventually, everyone infected will move to the final group.
The R class, which is removed or recovered, and a small number of people die as well, so that's why we usually call it removed, but recovered is close enough.
This is called dynamic compartmental modeling, and it's been used as far back as the 1920s. We're showing a bit of a simplified view. The full model goes deeper, with additional compartments for those in quarantine and those who are spreading the virus but don't know they're sick yet. BC's model also adds a separate track for those people who are physically distancing, since they spread the virus at different rates.
What we like about our model is that it captures the idea of distancing and the idea that not everybody can participate in distancing. Some people are not able to or willing to, and so it gives that tiny little bit of kind of realistic population behavior.
This is the key to finding the threshold Dr. Henry talks about. Not everyone distances, so creating the two tracks allows researchers to more accurately model and determine this threshold.
You have to understand that your model is not going to capture all the behavior of a very complicated system. And in this case, the system is incredibly complex. You basically got human society, an infectious agent that doesn't treat all people equally.
You know, if you think about lots and lots and lots of fish all swimming in a school, you could imagine that if you see where the school is headed, you could probably figure out around when it's going to get there without knowing how every single fish is flapping its fins.
But how do we know this model really works? First, we seed it with data from early in BC's pandemic.
So then what we do is we take the model and we pretend that it's March 1st, and we say, okay, there's a small number of infectious people in BC, go, and the model runs.
If the model is realistic, then we should see something that matches well with the case data from over the past few months. And it does just that. A good sign the model is on the right track. The team has been working on questions like what effect the US border opening would have on cases, how going back to school in September could change things, and what the best way to roll out a vaccine will be if we get one.
So you can't put 100 people in your lab and give them COVID and see what happens as they go out into the world. This is a terrible idea. Clearly we can't do that. But if we can fit our models to data, then we can explore what happens if we change something about what we're doing, what impact does that have on the cases, and then we can explore that by running the model forward.
It's pretty amazing that such a simple model can help us answer such big questions. Like a weather forecast, it can't predict the future, but it should inform your decisions. If there's rain in the forecast, bring an umbrella.
It's not a prediction of where we might be or how we might go. It's a set of parameters that allow us to make some rational decisions about planning.
So with that in mind, how should these results affect our own everyday decisions? How do we avoid restarting that rapid exponential growth?
Yeah, great question. So I would think we should be thinking of this a bit the way we think of a forest fire hazard. So I think in BC, we are used to the idea that if the forest fire hazard is extreme, don't light a fire. And I think we could start thinking about the COVID modeling this way. You know, cases are on the rise, And the only thing we know that has worked worldwide is staying away from each other.